Officer, your NBO. We're going to be discussing the largest and most complex space telescope ever built and launched into space. It has and will continue to fundamentally alter our understanding of the universe around us. So please join me on this journey as we explore the James Webb Space Telescope, beginning with the video voiced by the late Carl Sagan.
We have uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky. We've crossed the solar system and sent ships to the stars. But we continue to search. We can't help it. Essential element of the human future lies far beyond the Earth. Some cosmic purpose, then let us find ourselves a worthy goal.
Have you ever gone outside on a clear night and just looked up at the stars? Have you ever wondered what could be out there in the cosmos? Shout out some ideas. What do you think could be out there? Any guesses? Aliens? That's a good answer. Any other guesses?
Many galaxy, many universe.
Monsters? Maybe. Stars, planets, monsters, aliens, maybe. For centuries, we've wondered what could be out there in deep space. The earliest documented telescopes were pointed up at the stars as early as the 1600s by explorers like Galileo. Since the mid-1960s, countries from all over the world have launched telescopes into space to study the marvels of the universe. Some of these telescopes include the Compton, the Spitzer, the Chandra, and of course, the Hubble telescope. Who here has heard of the Hubble?
Yes.
A lot of people, right? Since April of 1990, this school bus-sized telescope has sent back thousands of amazing images from deep space. This includes photos of stars, planets, nebulas, galaxies, clusters, and far more. It took all these photos using mostly visible light. The last time the Hubble was even updated, however, was way back in 2009 by the shuttle crew STS-125. NASA's latest addition to this long line of amazing telescopes, the James Webb Space Telescope, is 6 times larger than the Hubble and will pick up where Hubble's capabilities left off. See, the James Webb doesn't just use visible light. Remember that there are several different kinds of light on the electromagnetic spectrum of energy. There are gamma rays, X-rays, UV rays, visible light, and infrared. These shorter wavelengths being stronger, and the longer wavelengths being weaker. The James Webb utilizes infrared light. This is significant because when stars and planets are first being formed, they're surrounded by dense clouds of dust and debris. Visible light from these weak stars cannot penetrate these clouds. Infrared light, however, can. Meaning that for the first time ever, we're able to see what's going on the inside. This orbiting infrared observatory has allowed us to see further into space than ever before. The James Webb was a long work in progress. Construction began back in 2004. In 2017, the James Webb was right here in Houston, Texas, across the street at Johnson Space Center. It was sealed off in the thermal vacuum chamber to help simulate the harsh environment of deep space. The James Webb is a joint project involving NASA, the European Space Agency, and the Canadian Space Agency. It launched December 25th of 2021 from the French and European spaceport of Kourou-French-Guiana. It launched on top of this heavy lift vehicle known as the Ariane 5 rocket. You can see the James Webb all folded up like origami inside the nose cone right over there. The Webb's primary mirror is made up of 18 hexagonal elements that are made of a material called beryllium. Beryllium is extremely resistant to the harsh conditions of deep space. The entire mirror is plated with a very thin layer of gold. Gold is very reflective and is sensitive enough to capture the weak wavelengths of infrared. The entire telescope is powered off of solar energy. The solar panels can be found on the bottom side of this sun shield right over here. This sun shield is made up of 5 layers of a material called Kapton. Kapton is a very thin, brittle, and foil-like material. So much so that whenever they're unfolding the web in space, they have to unfold it very, very slowly to prevent any ripping of this brittle Kapton material. Now guys, I know that this model looks pretty small, but the actual telescope is massive. The sun shield alone is 18 by 12 meters, making it about the size of a tennis court. So the actual telescope would take up pretty much this entire room. Unlike most space telescopes that have always been relatively close to the Earth's atmosphere, the James Webb is way out into deep space. For example, the Hubble telescope, which we all know and love, is only 570 kilometers away from the Earth's surface. That's around 300 miles or so. Whereas the James Webb is 1.5 million kilometers away from the Earth's surface. That's 930,000 miles away, making it further than the moon. To help you understand how far this really is, let me give you a few comparisons. For the space shuttle to reach orbit, it took 8 minutes. For the SLS rocket to reach the moon, it took 3 days. For the James Webb to reach its final destination, it took 2 whole weeks. And once it did reach its final destination, it took another 6 months to fully unfold to prevent any ripping of that brittle Kapton material. The Webb's final destination is a position known as L2. L2 is the Earth-Sun Lagrange point too. In this position, the Earth's gravity and the Sun's gravity cancel out completely, locking it into a position where it's always facing out towards the stars. In this position, the Webb is actually heliocentric, meaning that it revolves around the Sun as opposed to around the Earth. From this position, the Webb has a visual range of 13.6 billion light years away. But what is a light year? Let's find out. A light year is not only the name of a very famous Pixar character, but it is also a space-specific term used to measure the immense distances the light is traveling in the vacuum of space. If scientists were to use miles or kilometers to measure distance in space, they'd be forced to deal with gigantic numbers. So instead, they use a unit of measurement called a light year. A light year is a distance that light travels in the vacuum of space in 1 year. I know this sounds like a huge distance, but space is so massive that even a light year seems small in comparison. For example, this is Proxima Centauri. Proxima Centauri is the closest star to our Earth other than the Sun. It is 4.25 light years away. What this means is that the light that we're seeing from Proxima Centauri on Earth right now left the star over 4 years ago. It's kind of like looking back in time. To give you another example, our own sun is only 8 light minutes away from the Earth. So if you're to go outside and look up at the sun, don't actually look up at the sun, but if you were to do that, that's what the sun looked like 8 minutes ago. The James Webb Space Telescope is a huge leap forward in our quest to understanding the universe and its origins. The Webb is studying every single phase in cosmic history, from the first luminous glows of the Big Bang, to the formation of the first stars and planets, to the evolution of our very own solar system. The James Webb is helping us answer questions like, how are galaxies formed? And what does the life cycle of stars really look like? The James Webb is even helping us study the atmospheres of exoplanets, potentially discovering the building blocks of life, like water vapor, somewhere outside of our own Earth. In fact, the James Webb has recently discovered evidence of dimethyl sulfide located on a planet 120 light years away from the Earth. Dimethyl sulfide, as far as we know, is a compound only produced by light. One of the very first images sent back by the Webb telescope was received July of 2022. This image is known as Webb's first deep field. It captured a detailed look in infrared of galaxy clusters. That's right. Each of these colorful swirling formations are individual galaxies. Can anyone tell me what galaxy we're in right now? Chat that if you know.
Milky Way.
The Milky Way, exactly.
The kid is smart.
Any of these colorful swirling formations could be a galaxy just like our own. And this looks like a lot of galaxies, right? This image only covers a patch in the night sky about the size of a grain of sand when held at arm's length distance from someone standing on the ground. Let's take a look at the Stefan's Quintet. The Stefan's Quintet is a visual grouping of 5 galaxies best known for being prominently featured in the holiday classic film, It's a Wonderful Life. Here you can see these galaxies pulling at each other due to all the different gravitational interactions. Most notably, you see that red portion right there?
Mm-hmm.
That red portion is actually a series of shock waves as one of the galaxies smashes into the other. This image is very important because it helps us understand what happens when galaxies interact with one another. Here we have the iconic Pillars of Creation. Now these may look like majestic rock formations, but they're actually made up of dense clouds of dust and debris in which stars and planets are forming. This cool interstellar gas in infrared light looks near transparent. Now we will check that out in just a second, but I do want all of you to note, you see that longest pillar right there? That longest pillar is 5 light years long. Now let's check out the comparison. On this side, you will see the Hubble telescope photo taken back in 2014 using mostly visible light. Now take a look at this photo, taken by the James Webb Space Telescope using infrared light just in 2022. Although the photo by the Hubble is beautiful, look at all the stars that we were missing. Because of the James Webb, we have seen further and clearer than we ever thought possible. And this is just the beginning. Let's take a look at the Southern Ring Nebula. A nebula is basically a giant cloud of gas in deep space. This nebula specifically is sometimes referred to as the H-burst nebula because when seen through some telescopes, it kind of looks like a bigger H. These two images were taken with different variations of infrared light. This nebula is half a light year in diameter and is 2,000 light years away from the Earth's surface.
Wow.
Gas is moving away from the dying star in the center at a speed of 9 miles per second. This is sometimes referred to as the final act of the dying star. At 161,000 light years away in the Large Magellanic Cloud Galaxy lies the Tarantula Nebula. The Tarantula Nebula is the largest and brightest star-forming region nearest our own, It is home to some of the hottest and most massive stars that we know of. Finally, at only 7,600 light years away, lies this beautiful landscape, full of mountains and valleys, speckled with millions of glittering stars, is actually a nearby star-forming region known as the Carina Nebula. So the next time you guys go outside on a clear night and just look up at the stars, I want you to remember that you're actually looking back in time.
She's from India.
See, all those stars that you see
Very smart.
are millions upon millions of miles away from the Earth.
She memorized
And the
it.
light coming from those stars takes time to reach the Earth's surface. Let's say that there's a star 10 light years away, and it disappears right now. We wouldn't even know about it until 10 years later, because the light coming from that exploded star would still be traveling towards the Earth. With the James Webb Space Telescope, we now have the capabilities to look deep into the past to see when stars and planets were first being formed. We ask ourselves questions like, how are galaxies formed? What does the life cycle of stars really look like? And are there other planets capable of holding life similar to our own Earth? These answers are out there in the unexplored darkness of space. With the James Webb, we not only hope to answer these questions, but also inspire a new generation of astronomers and scientists that will, one day, unlock the secrets to the universe. So for more information on this exciting new mission, definitely check out any of our social media pages right over here. I also highly recommend coming up to the front to check out the cool James Webb Space Telescope model that we have. If you guys have any questions at all, please feel free to come up and talk to me. I love answering questions. Otherwise, thank you all for joining me, and I hope the rest of your day is out of this world. Bye, guys.
Bravo!